warahmatullahi wabarakatuh. My name is Kautsar Hasanah Binti Khairi and my supervisor is Mr. Muhammad Asrul bin Ashrad. Today I am going to present you KatMana progressive web application which are developing LRT-based journey planner using geolocation with nearby place recommendation using linear search algorithm with the tagline Explore the city to the tracks. For the project background, this project was inspired by true events where I have to go to the post office but I don't have any car since I rely heavily on public transport. However, it is difficult to search post office that are nearby the public transport. So the idea came whereby using geolocation, we can actually locate one, and to enhance the search, I implemented nearby place recommendation using linear search algorithm. For the problem statement, I have conducted a survey which was responded by 35 respondents. First is the difficulties in locating and searching for places nearby LRT station, and second is difficulties in planning an LRT-based journey. There are three objectives of this project. First is to design KatMana progressive web application using geolocation to assess the user's location, locate and search places nearby LRT station. Second is to develop KatMana progressive web application using nearby place recommendation with linear search algorithm to find the nearby places based on user preference that are 150-meter radius from the LRT station. And lastly, to evaluate the effectiveness of KatMana progressive web application using geolocation and nearby place recommendation with the linear search algorithm in terms of accuracy, functionality, and usability. The significance of this project are to provide a proper medium to locate and search places nearby LRT station, and secondly, easy to plan LRT-based journey to find nearby places. KatMana has three project scope. The first one is the audience, which are user and admin. Next is functionality, where this application can locate and search nearby places within LRT station and recommend nearby places to plan an LRT-based journey. Lastly is location. The location involved is places that are 150 meters radius from the Kelana Jaya Rock station. This is the use case diagram. The user has three modules, which are Assess Location module, Searching module, and Trip Planning module, while the administration has two modules, which are Login module and Station module. These are the flowcharts of the system. First is Assess Location module. When the user is at the home page, Assess Location module will be implemented. The system will request the permission of the user to assess the user's location, and then the nearest station will be shown. Second is the Searching module. Searching module is when the user enters station and places that the user preferred, and then the system will find the list of nearby places according to the user preference. This is the Trip Planner module flowchart. From the home page, the user needs to go to the planner page. The user needs to input starting station, and they have the choice to add an ending station. After that, they need to input place 1. The user can also input place 2, and they have to choose the station option. And then the Trip Planner module will be implemented. After that, the results are shown, and the user have the choice to do it all over again or to end it. This is the Login module for the administrator. If the administrator is already signed in, it will be directed to the home page. If not, it will require the admin to sign in. And when the admin is at the home page, the admin has the choice to log out. These are the Station module flowcharts. The admin can add, edit, and delete the station. This is the system architecture of KatMana application. First, the system will use geolocation to locate the user's location. Second, it will integrate with Google Maps API, Google Geocoding API, and Google Places API, and Google Distance Metrics API. And it will be integrated to perform nearby place recommendation using linear search algorithm. Next, the system uses Bootstrap as a front end and Laravel framework as a back end. Now let's proceed to the system. KatMana is a progressive web application, so it can also open at mobile. So at first, it will ask you to allow your location, and your location will has been found. Since there is no nearby train station that is 150 meters from your current location, it will show you 0 places found. And since it is a PWA, you can install your application. This is the application in the desktop app. So in this page, in this system, it has 3 pages, that is nearby page, planner page, and admin page. Nearby page is when you want to search for a specific place from certain station. For example, I am at station Gombak and I want to know if there's a nearest post at station Gombak. So as you can see here, it shows you 1 place found. So I will click the marker and it will show you the details of the place. Next, let's go to the planner page. This is the planner page. You can plan your journey here. For example, you want to go to the nearest optometry, but you don't know where. So let's start with, you are at Wangsa Maju and you want to go to the optometry. And then you will find the nearest optometry from Wangsa Maju that can be accessible by public transport. For example, the nearest optometry is at iPops Eye Care. It is at Wangsa Maju, the current station, and it is 5 minutes from the LRT and only took you 300 meters for walking distance. And then you can also choose your ending point, or you can add a second place. For example, from Wangsa Maju until LCC, and then you want to search for KFC and Pos Laju, and you have to choose between single station and multiple station. What it does is, the single station, it will find these both places in the same station, and the multiple station will find the nearest of both places at multiple station. So this is the single station. Let's check whether KFC and Pos Laju can be found in a single station. So as you can see here, KFC and Pos Laju can be found at Ampang Park. So it is 6 stations away, and it only takes 7 minutes and 500 meters, and this 3 minutes and 200 meters from the station, from the Ampang Park station. And then let's find if there's a multiple station. So from Wangsa Maju to KLCC, and the chosen place is KFC and Pos Laju for multiple station. You can find KFC at Ampang Park, the nearest KFC from the Wangsa Maju, and then Pos Laju is at LRT Sri Rampai, is at Sri Rampai station, is 1 station away. And let's go for the admin page. Admin page is where you can manage the station information. You can create new station. For example, code is 1 and name, let's say Sri Mutiara, and latitude, we take a random latitude and longitude, same. For status, we can choose it is active or inactive. So let's create this station, and as you can see, the station has been created. So you can edit the station say this, and it has been updated, and you can delete the station. And as you can see, there's no station. The station has been deleted. And then, so let's say I want to edit this Ampang Park. I want to make it inactive, and it has updated to inactive. And then we go as a normal user. As you can see, there's no Ampang Park in this list to prevent the user to click an inactive station. So for example, we know that in Ampang Park there's KFC. So we start from Mangsa Maju and we try to search for a KFC. Let's see if Ampang Park is in the list. So as you can see here, it's supposed to show Ampang Park, but since the Ampang Park is inactive, it will show the next nearest KFC, that is at KLCC. It's only 200 meters and 2 minutes away. So now I'm going to explain the logic behind the journey planner. First, the system will get all the information of the active and inactive station. Then it will get all the user's input: the first place, second place, starting point, ending point, and the station option. Then the system will filter out if the user input the ending point, and if the user input the second place, and it will go to the search. There are two types of search, that is search forward and search backwards. As you know, the rail tracks have two directions. It moves to the right and it moves to the left. So I split it into two directions, and it will search for the nearest place between the right direction and to the left direction. Then it will filter out the inactive station. If this inactive station, it will not go into this bracket, and then it will get the latitude and longitude of the current station. For example, the starting index. Starting index is the current location, and it will search the nearby place from the current station. If there's no result, it will go looping all over again. So this is the algorithm, the linear search algorithm. It will check, and in every station, if there's a nearby place that is, for example, KFC, it will check, and if there's a result, the information of the result will be collected. For example, the latitude and longitude of the place, for example the KFC, it will collect the latitude and longitude, and then it will calculate the distance from the LRT and the duration, walking duration from the LRT, and it will save in a database, and it will return the data. So this is only the logic for if the user hasn't put an ending point and the user hasn't put the second place. And this is the example. If the user has put the second place, it will filter out if the user has put option single mode, and it will search for the first keyword and second keyword, and if there's a result, they will go into this bracket and will fetch the data about the place. If does not have result, it will loop, and if there's no result, it will show you no result in the web page. And that's all. Thank you.